Hello everyone, this is Kinjal Parmar. In previous session we discussed about analog to digital converter, in which we discussed about various types of analog to digital converter. In previous sessions we discussed about a flash comparator type analog to digital converter, then successive approximation analog to digital converter, then counter type analog to digital converter. In today's session we will discuss about fourth type of analog to digital converter, that is dual slope analog to digital converter. So let's start. Dual slope analog to digital converter. The dual slope analog to digital converter is one of the slowest but relatively inexpensive because it does not require precision components such as a DAC. As we discussed in a previous session that in a successive approximation type analog to digital converter and in a counter type analog to digital converter, we use this digital to analog converter which require a precision. So this dual slope analog to digital converter is a quite slow, but we have to eliminate this digital to analog converter need into this dual slope analog to digital converter. So this dual slope analog to digital converter is one of the slowest but relatively inexpensive of analog digital converter because it does not require precision components such as a digital to analog converter. The basic principle of this digital to analog converter is that the voltage reached by the ramp signal controls the length of time that the binary counter is allowed to count. In a counter type, we used a AND gate and a comparator to control the counter. Here we use a ramp signal to control the binary counters, and we control this binary counter up to the value of analog inputs, and this length of time required by binary counter to count the value up to the binary up to the analog input is controlled by a integrator. Thus a binary number proportional to the value of input voltage is obtained by two integration. It is also known as integral type analog to digital converter. The basic principle of this digital to analog converter is the voltage reached by the ramp signal controls the length of the time that the binary counter is allowed to count. Thus, a binary number proportional to the value of input voltage is obtained by two integrations. It is also known as an integrator type analog to digital converter, as we use integrated circuit over here. A dual slope analog to digital converter use an operational amplifier to integrate analog input. Here this analog input can be integrated using operational amplifier and resistor and capacitor component. The output of the integrator is a ramp whose slope is proportional to the input signal, and this proportional a ramp signal is used to control this binary counter. Here the output of the integrator is a ramp whose slope is proportional to the input signal since the component R and C are fixed. How we can convert analog information into digital information using this dual slope, or says using this integral circuit? So here we have a diagram of dual slope analog to digital converter. Here we have a two inputs, analog input and reference voltage. According to requirement of binary counters control circuit, we can trip over analog input or at a reference voltage according to our requirement. So we have a two connections for analog input and for reference voltage. Now here we have a circuit that is operational amplifier, resistor and capacitor. This phenomenon is known as a integrator circuit which integrates the input and produces a ramp signal. Now this slope of this ramp signal is exactly equal to, or says exactly proportional to, the time required binary counter to count the value approximate near to this analog input. For example, we have a 10.2 analog input. So this integrator integrates the value and produce the ramp signal which is exactly proportional to the binary counter, which requires the time duration to count from 0 to 10, and this binary counter allows to count the value from 0 to 10. After reaching this 10, basically a ramp slope of ramp signal is basically changed. So we have a no clock over here and binary counter must be stopped over there, and using control circuitry, this after stopping this counter, this switch its control to analog input to the reference input. For example, if we have a 10.2 input signal over here, says we have a 10.2 over signal here. Initially this switch is connected to here, then we have a integrated circuit, so we have a ramp signal over here like this. Basically we have a slope type, and this slope is basically a time amount of time which is used to require binary counter from 0 to 10. Now here we consider this as a positive value, so our reference voltage must be negative, and if our analog input is negative, then reference voltage must be positive for a correct ramp signal. So using this positive negative combination, we can control this binary counter. Now here we have a ramp signal like this, and slope of this is compared with this. So we have a comparator. Here we have a positive value which is connected to the ground, so basically we have a 0. Here for a positive value we have a negative slope, and for negative again these values can be converted over here as a positive, because negative negative positive, so we have a positive value, so we have a 1, so 1 into clock, so this binary counter start counting, and this value positive difference remain up to for a negative slope over here. Whenever we have a positive slope for a greater than value from this 10.2, we have a 0 over here. Whenever a slope of this becomes positive, so we have a negative difference, because we have a here only negative terminal, so we have a minus and minus of, so we have a total positive value. But whenever we have a positive slope, so we have a only negative value. For a positive value over here we have a negative slope over here, and for negative value we have a positive slope over here. So if we have a negative slope, that means we have a value which is uh, controlled, or says which is nearly approximate equal to this 10.2. So we have a negative slope for a 10.2 value, and after that we have a positive value. So for a positive value we have a 0 over here, because we have a negative difference. For negative value we have a positive difference over here. So for positive value we have a 1 into clock, so we have a clock, binary counter counts the work and start the counting. It counts up to 10, and after 10 we have another values which has a positive slope, and for positive we have a 0 over here, 0 into clock 0. So after 10 this binary counter stop the counting, and this control circuitry controls the switch, and switch is stripped over reference voltage, and this reference voltage is basically a negative voltage which makes this total circuit to stop over there. So we have a digital output 10 over here. So this is how dual slope analog to digital converter works. Now we have another type of analog to digital converter also. We can convert analog to digital converter using conversion method, An analog to digital converter can also be implemented using frequency or time conversion. According to this analog to digital converter can be classified as voltage to frequency analog to digital converter or voltage to time analog to digital converter. We have a two types of conversion method: voltage to frequency, voltage to time. So let's discuss about this type of analog to digital converter. We have a first voltage to frequency analog to digital converter. A voltage to frequency analog to digital converter converts analog input voltage to a pulse train with the frequency proportional to the amplitude of the input. A voltage to the frequency analog to digital converter converts the analog input voltage to a pulse train. Pulse train, that means we have a 1010 pulses over here, and the frequency of this pulses is proportional to the amplitude of the analog input. The pulses are counted over a fixed period to determine the frequency, and the pulse counter output in turns represent the digital voltage. It consists of voltage to frequency converter. Voltage to frequency converter is a converter device which converts voltage into frequency. Then we have a timing circuit and a pulse counter. A voltage to frequency converter is an oscillator whose frequency is linearly proportional to the control voltage. This frequency is fed to a counter to be counted for a fixed time interval. The final count is proportional to the value of analog input. This output of voltage to frequency converter. So we have a frequencies over there, and this frequency is fed to a counter to be counted for a fixed time interval. The final count is proportional to the value of analog input. Here we have a basic diagram of voltage to frequency analog to digital converter. This analog input is given to voltage to frequency converter. So this analog voltage can be converted in terms of frequency. Now this frequency can be given to the pulse counter to count the value into digital form, and this timing circuitry controls the value of this voltage to frequency converter using a clock signal. So this digital pulse train can be converted into digital output using pulse counter. Then we have a next voltage to time analog to digital converter. A voltage to time analog to digital converter converts analog input voltage to a pulse train with the time proportional to the amplitude of the input. In previous, frequency is proportional to the input. Here time is proportional to the input. It converts input voltage to a pulse delay time by using voltage to time converter, and then pulse delay time is converted to a digital word by using time to digital converter. So here we have a basic diagram of voltage to time analog digital converter. Analog informations can be converted into pulse form using voltage to time converter, and then this pulse form can be converted into digital form using time to digital converter. So using these two blocks, we can convert analog information into digital form using voltage to time conversion method. So in this session, we discussed about a dual slope analog to digital converter and further analog to digital conversion using various conversion method. Here we discussed about voltage to frequency conversion method and voltage to time conversion. Thank you.